All right, senior math, welcome back. Today, we are kind of doing our last little lesson over this z-score portion of our z-score unit, stats unit. We're going to finish up the z-score unit, and then this will be our last sort of lesson, then we'll have some review time next week, and then we'll take our assessment over this that week as well. So next week you can expect an assessment. So you have the warm up. What does 95% confident mean to you? So 95% confident, I assume you would assume the same response would be that you're almost completely positive about a certain event or about a certain piece of information. You are almost positive. You are 95% confident that something is true or something is however you think it is. So it means you are very positive. You're very confident behind your stance on a specific topic. So we are going to talk about 95% confidence intervals. So sometimes when you're looking at data, you want to estimate the current mean of a population using a small amount of data. So sometimes it's very, very, very difficult to find the mean of an entire group, an entire population, because that would mean surveying every single person in that entire population, or having to look at every single item in that entire population. That's very difficult. What is much easier to do is take a smaller sample set of that population and then find the mean of that, and we can then use that smaller sample set to help us get an idea on what that larger population mean is. So we're going to look for the mean of a sample set and use that to help us come up with what the mean of the entire population is. But now there's some variability to this. Like we know our answer, we know we can't get an exact answer of the entire population's mean just by asking a small group. So what we're going to do is we're going to find a range that this mean is going to fall in between. We're going to find a distance of between what two numbers should this mean have to be between. And we're gonna use a confidence interval to help us. So we're gonna figure out so that we are 95% confident that the mean would fall between two numbers. So you're going to be almost completely positive that the mean would have to fall between these two numbers. So what we mean by a confidence interval, this 95% confidence interval, if we think about our bell curve, our z-score bell curve, we got our bell curve there. We always know that for this z-score, the mean is always the direct center of your z-score. The mean is the direct center of your z-score. And then for how far away we get away from that mean, certain standard deviations away, like 1 standard deviation away, and then 2 standard deviations away, and 3 standard deviations away from our mean, can create different percentages. So we know using Chebyshev's theorem that we talked about at the very beginning of the year when we were talking about standard deviation, we know Chebyshev's theorem represents about 75% of our data falls within 1 standard deviation away from our mean, while 89% of our data falls between 2 standard deviations from our mean, and 3 standard deviations fall between, or like 99% of our mean, because of how distributed our normal distribution is. And we could use that z-score table to help us figure out what was the percentage of distribution at a certain number of standard deviations away. So at 3.9 standard deviations below our mean, there was only 0.0005% of the data that was going to be lower than that value because it was always less than. So we think about this. We want to be 95% confident about our data. So we want 95% of our data to be around that mean. So this big green space, I want it to be 95% of all of my results. %. So that means this leftover space below my mean is only going to be below and above on both ends. It's only going to be 5% in total. So if I think about it, all 100% minus 95% is going to leave me with 5%. But that 5% is being split up evenly among two regions, the bottom and the top half. This bottom region down here and this top half up here. So if I split 5% into two pieces, it's going to be 2.5% each. So each of these little red areas is only 2.5% of my data. So if I can figure out what is the z-score at this red line here and the z-score at this red line, that should tell me how many standard deviations away from my mean will give me 95% of my data. How many standard deviations below and how many standard deviations above my mean is going to represent 95% of my data. So let's look for this. So this line right here, thinking about our z-score backwards, which is what we did on Wednesday this week, this line right here represents 0, 2, 5, 0, 0. So we're going to find this number on our z-score table. 0, 2, 5, 0, 0. If we look, is actually right here, 0, 2, 5, 0, 0. And this is negative 1.90, 1, 2, 3, 4, 5, 6, negative 1.96. So this value right here, this z-score, is equal to negative 1.96. Well, based off of how our z-score table works, it's symmetrical. So this number up here is going to be positive 1.96. So 95% of our data is always going to fall between negative 1.96 and positive 1.96 standard deviations away. So almost 2 standard deviations away. I know my table doesn't line up perfectly, but almost 2 standard deviations away should encompass 95% of our data. So using this and then using the data from that small sample set, we can estimate that the mean would have to be between these two values using this formula here. So what this formula says is that X represents the mean of the sample set. So of those small group of people that you interviewed, that mean is going to be represent X in this formula. 1.96 is our 95% confidence. We know 95% of the confidence is 1.96 standard deviations away. Sigma is going to be the standard deviation that we're given from that sample set. And then lastly, we have n, but it's the square root of n. So this represents the number of samples. So the number of people that were sampled or the number of items that were sampled is represented by n. So what this formula is saying is if I take the mean of my sample set and if I add 1.96 times the standard deviation divided by the square root of my number that is sampled, this will give me the above value, the top end of my 95% confidence interval. I know that my mean I have 95% confidence that my mean is not going to be bigger than this result. Same idea below. It's the exact same formula, except it's subtraction rather than addition. I am 95% confident that my mean should not be, of my entire population, should not be below this value. And so between these two ranges, between this low number and this high number, our mean should always fall between those two numbers. So we can be 95% confident that if we get these two ranges, that our mean of our entire population is always going to fall between those two numbers, which helps us get a good idea of where that mean is and helps us estimate what that mean should probably be. So the superintendent at Ridgemont wants to find the average age of all high schoolers, students, in the past, of all high school students. In the past, the standard deviation was 1.4 years. If 25 students are randomly selected and had an average age of 15.7, find a 95% confidence interval for the entire school. So let's start by looking at the information. So we were told in the past, the standard deviation was 1.4 years. 25 students were randomly selected, and they had an average age of 15.7. So we know our formula is, or let's first write down what those things is. So X is my average. I was given an average of 15.7. I got a standard deviation of 1.4, and I had an n of 25. So I'm doing two formulas. One where it's x plus, sorry, that's a bad x. Let me make a better x. X plus 1.96 times the standard deviation divided by the square root of n. And then I'm also doing x minus 1.96 times the standard deviation divided by the square root of n. So both of these are going to have the exact same information. The only thing different is one is going to be plus and one is going to be minus. So if I fill in this information, x was 15.7, so it's 15.7 plus 1.96 times my standard deviation, which was 1.4, divided by my square root, which was 25. And my bottom one is going to be 15.7 minus, 1.96, because this is my lower end of my interval, times 1.4 divided by square root of 25. So these are going to give me two numbers that I know my mean of my Ridgemont population, my entire population, the entire high school, has to fall between these two numbers. Now we can plug this whole formula into the calculator. I can do 15.1 or 15.7 times or plus 1.96 times 1.4 divided by the square root of 25, and that gives me, for the upper end of my data, it gives me 16.25. I can then plug in this lower value, 15.7 minus 1.96 times 1.4 divided by the square root of 25 is going to give me 15.15. So I know the mean of my data. I'm 95% confident that the mean of my data is going to be bigger than 15.15, but less than 16.25. It needs to fall between those two numbers, and that is my 95% confidence interval, that the mean average of all Ridgemont high schoolers is going to be somewhere between 15.15 years old and 16.25 years old. And I'm 95%. Let's look at another example. So a certain medication is known to increase the pulse rate of its users. The standard deviation of the pulse rate is known to be 12 beats per minute. If the sample of 30 users had an average pulse rate of 104 beats per minute, find a 95% confidence interval for the true mean. So once again, let's write down our data let's write down our information that we know. All right, so we see standard deviation is 12 beats per minute. The sample of 30 users had an average pulse of 104. So our average is 104. Our standard deviation was 12. And our number of users, our sample size, is 30. So plugging that into our formula, we are going to have our average plus, actually, I don't like red. Sorry, let me choose a different color. We're going to have our average plus 1.96 times our standard deviation of 12 divided by the square root of 30. So our average plus our 1.96 confidence interval divided by, or times our standard deviation divided by our sample size. And then once again, you can plug both those into the calculator. So I can plug 104 plus 1.96 times 12 divided by 30, or square root of 30, in my calculator, and I get 108.29. And then I can plug this lower value into my calculator, except once again I wrote plus again. This should be minus 104 minus 1.96 times 12 divided by 30, square root of 30, gives me 99.7. So the average standard deviation, the average mean of every person on this medication should be somewhere between 99.71 beats per minute and 108.29 beats per minute. So the average beats per minute, the average pulse rate of anyone on this medication is always going to be between those two numbers. I'm 95% confident on that. Last example. All right, a sample of 50 days showed that the Taco Bell served an average of 182 customers during lunchtime. The standard deviation of the sample was 8. Find the 95% confidence interval for the mean of all days. So how many customers, what is the average number of customers that this Taco Bell would serve on any day? We can use that using our sample. So we know it's X. Our average was 182 of the sample. Our standard deviation was 8. And our N, our number of days that we're looking at, our sample size is 50. So plugging this in, we have 182 plus 1.96, that confidence interval, times 8 divided by the square root of 50. And then 1.82 minus 1.96 times 8 divided by the square root of 50. Plug both these into my calculator. Plugging the plus 1 in first and then the minus 1, I have 184.21 and 179.78. So I am 95% confident that 1.79 is less than my mean, which is less than 184.21. So I'm 95% confident that my mean falls between those two values. And that is our 95% confidence interval. So you'll have a little bit of practice over this, where you'll be finding the mean population, or using sample sizes to find the mean of the entire population using this 95% confidence interval formula. Once again, there's your formula right there. It's not too hard. It's pretty easy. Just filling in the X, the standard deviation, and the sample size, doing a plus, doing a minus, and then writing it out, and you have your answer. So have a great rest of your day. Let me know if you have any questions.